All right, good morning, fifth graders. It is Wednesday, May 20th, and we are working on week 3, day 2 in your packet. So on this one, I'm not sure why they call it Beat the Calculator. Jamal is playing Beat the Calculator. Help Jamal solve the following problems, show your work. All right, we don't need a calculator to do this. All right, so for instance, on this one, you cannot do this unless you make the denominators the same. Remember, we cannot add or subtract fractions unless the denominators are the same. So the first thing we want to do with all these problems actually is change any numerator or denominators that aren't the same and make them the same. So first thing we want to do is write it vertically because it's easier to work with. So now see if you can use one of the denominators that's already in your problem. That's the easiest thing to do if we can. So will 5 go into 10 evenly? Yes, it will. So let's use 10, and then we say 5 times what equals 10. We know that's 2. So whatever we do to the bottom, we have to do to the top. So 1 times 2 is 2. And then we don't want to forget about our 1. Our whole number 1, we don't want to forget about that. So I'm going to put it there in a different color. So 1 1/5 is the same as 1 2/10. All right? All right. So now we're just going to keep this 3/10, 3/10. All right? So now we can subtract. So we only can subtract the numerators because the denominators stay the same. So we can't take 3 from 2. So we have to borrow from this 1. Then this becomes 0. And now we have to change that 1 into a fraction using the denominator that we're working with. So what is 1 with the denominator 10? Well, we know that anytime a number is over itself, that's 1. So borrowing 1 is the same as borrowing 10/10. So now, because these are the same denominators, we can add 10/10 to 2/10, and we get 12/10. Now our top number is bigger than our bottom number, and we can subtract. 12 take away 3 is 9. Okay, so your first answer here is 9/10. Okay? All right, you're going to do the same thing on all the rest of these. So remember to write them vertically. So 1/3 plus 1/4 plus 1/2. And remember, we cannot add these. So please don't add, 4 plus 2 is 6 plus 3 is 9, and then 1, 2, 3, 3/9. You cannot do that. In fractions, you cannot add or subtract unless the denominators are the same. So what we have to do is make them equivalent, find a number that will 3, 4, and 2 will all go into. So remember when we wrote the multiples? So it's like skip counting. 3 plus 3 is 6. 3 times 3 is 9. And then what comes next? 12, 15, 18, and so on. So we put dot, dot, dot there to show that we're continuing. All right, so now we have to find fourths. So let's skip count 4. 4 8, 12, 16, and then we're going to do dot, dot, dot. It continues. All right, and now we're going to do 2. We're going to count by 2s. 2, 4, 6, 8, 10, 12, 14, dot, dot, dot. All right, so now we have to find a number that's in all 3 rows. So for instance, 6 is here and here, but not in this row, so we can't use 6, okay? 4 is in this row and this row, but not this row, so we can't use 4, all right? So let's look at 12. 12, 12, 12. That looks like it's it. Okay, that's the lowest common multiple. So then we're going to come up here and make this 12 the denominator. This is going to be 12, and this is going to be 12. All right, now 3 times what is 12? We know that's 4. And we know the rule that whatever we do to the bottom, we have to do to the top. 1 times 4 is 4. All right? All right, 4 times what is 12? We know that's 3. And then whatever we do to the bottom, we have to do to the top. And then 2 times what is 12? 6. And then whatever we do to the bottom, we have to do to the top. 1 times 6 is 6. All right, so now we're ready to add, but we don't add the denominators. The denominator stays the same. But we do add the numerators. So 6 plus 3 is 9. 9 plus 4 is 13. All right, so here's the thing though. This is an improper fraction. Do you remember how to change an improper fraction to a mixed number? We have to divide 13 divided by 12. 13 divided by 12. So what this means is you have 13 and they want to know how many groups of 12 are in 13. So you see this? 1 group of 12 is in 13. 1 times 12 is 12. And then we subtract. 3 take away 2 is 1. This 1, the remainder, becomes the new numerator, and this is the denominator. So the answer to B is 1 and 1/12. All right, I hope that helps. I'm going to leave 2 of them for you to do, and I'm sure you'll do just fine. And if you need help, let me know, but I think you'll be fine with it. So let's take a look at the next one. Okay, now on D, guys, I think they're trying to confuse you, but there is actually a way of finding the common denominator here. It's actually 6,912, but there's actually an easier way to do it. I'll work with you on finding common denominators with 2-digit numbers next year. But if you look at this, 12 24ths, well, half of 24 is 12, so 12 24ths would reduce to 1/2. Okay? And then what's half of 36? Half of 36. Half we divide by 2. Aha! How many 2's are in 16? 18. So half of 36 is also 1/2. And then half of 48, 2 times 2 is 4, 8, 4, 24. So 24 48 is half. So if you were to add these up and get 3/2 and then reduce that, how many 2's are in 3? 1. 1 times 2 is 2. Subtract. This 1 becomes the new numerator, and this is the denominator. So you can see that 1/2 and 1/2 is 1 whole plus 1/2, 1 and 1/2. Okay, so this answer is 1 and 1/2, which we found an easier way than doing all that work, which it doesn't always turn out easy like this, believe me. All right, I am going to leave this one for you. So you have to make sure you have a common denominator. They're trying to trick you again, but you're going to write up 7/8 minus 1/4 vertically, okay, and find a common denominator. Well, 4 will go into 8, so you can use 8 as the denominator. So do that and subtract and see what you get. And then from that, look what you're subtracting. 5/5 we already know is 1, minus 3/3, which is 1. So 1 take away 1 is 0. So whatever you get here, you're going to subtract 0 from. So the answer is whatever you get here. Okay? All right. All right, let's see this one now. Okay, guys, well, this is an interesting one, isn't it? So one way to do this is to divide. So if you have your calculator there, go ahead and put in your calculator 1110 divided by 1111, and you will get, let me write this down for you so that we can compare them together. You will get 0.999 0.9. It keeps going, but I think we can stop there. I think we can stop right there. Let's see, 0. Let's see, let's go one more. 0.99991. Okay, that's this one. All right, so now on your calculator, clear that and put in 2221 divided by 2223, and you get, I'm going to change the color so that we can keep them clear. This one, the second one is 0.99910. All right, let's change the color again, and we'll put 3331 divided by 3334, and we get 0.9991000. 0, 0, 1, 8. All right, so now we can compare them. You know that once this gets to 1, 1, 1, 1, it's over 1, 1, 1, 1. That's 1. So that's why these are all 0.999. They're very, very close to 1 whole, okay? But let's see which one of these is bigger. Okay, and you see what we did to change these fractions to a decimal. We just divided the top by the bottom. All right, so now look. Okay, so we can look at this and let's evaluate it. Let me find another color that we haven't used so I don't confuse anybody. Okay, so you see that the 999s are all the same in these, right? Okay, so next one is 0, the next one is 1, the next one is 1. So we can right away eliminate this because 0 is not the same as 1. You see, it's less than 1, so we're going to use these two numbers because the next ones were 1s. All right, so we got 1, 0, 0. We've got 1, 0, 0. Now we've got a 1 here, and we've got a 3 here. Okay, so which is bigger? 3. So this is going to be the biggest fraction right here. Even though it's off by just a teeny tiny bit, that's actually the biggest fraction. And you can kind of look at it like this. See, this is 18, this is 31. You see that? So even though they're off by just a teeny tiny bit, that's how you do that. You just change them to, say, decimals, and then they're easier to compare that way. All right. Let's move on. All right, so on this one, it says, how many do you see? What did you count? How did you count them? Okay, so this, and this are the same, aren't they? If we draw a line here, we have 2 more of those, don't we? And if we draw a line here, and if we draw a line here, we have 2 more. So it doesn't say specifically that we have to have triangles, otherwise we could divide those into triangles, but it doesn't say that. It just says, how many do you see? What did you count? So what these are called are trapezoids. So how many do you see? We could say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Well, I see 12 trapezoids. How did you count them? You just counted them and you divided these. 1, 2, 3, 4, 5. These are hexagons. 6-sided figures, hexagons. You just divided them in half to make 2 trapezoids. Okay, so that's what I would say. I mean, I count 12. Unless you see something else. I mean, if you wanted to, if you really wanted to, you could make these all triangles. So one of these hexagons, or no, one of these trapezoids equals 3 triangles. So you could add all these up, 1, 2, 3, oh, we said 12, right? So you could say 12 times 3, you get 36 triangles, if you want to see it that way, okay? If you want to see hexagons, you could put 2 of these together and make another hexagon, so that's 1, 2, 3, 4, 5, 6, 6 hexagons. So maybe you saw 36 triangles, triangles, 6 hexagons, and what did we say? We said 12 trapezoids. Okay, so you decide which way you want to do it and how you want to count these, okay? All right, guys, we will see you tomorrow.